Hello, my name is Michael Iverson. In this presentation, I will be comparing the user interface design of two augmented reality IoT devices, the Ray-Ban Meta smart glasses and the Xreal Air 2. This analysis is based on usability principles, specifically Shneiderman's 8 golden rules of interface design. The goal of this analysis is to evaluate the user interface design and overall usability of these two devices. To do this, I apply Shneiderman's 8 golden rules, which are widely used guidelines for effective interface design. Ultimately, the objective is to determine which device provides a more usable and user-friendly experience. This topic is important because augmented reality wearables are growing rapidly in today's technology landscape. User interface design plays a critical role in whether users adopt or reject these devices. A poorly designed interface increases cognitive load and makes systems difficult to use, while a well-designed interface improves efficiency, accessibility, and overall user experience. First, let's look at a quick overview of the two devices. The Ray-Ban Meta smart glasses focus on AI-powered interaction using voice commands and touch gestures. In contrast, the Xreal Air 2 is designed as an augmented reality display, offering immersive visual experiences through virtual screens. These devices clearly take very different approaches to interaction. These differences are also reflected in the companies behind the products. Meta is a large global technology company with billions in revenue, while Xreal is a smaller startup focused on augmented reality innovation. Because of this, Meta prioritizes accessibility and mass adoption, while Xreal focuses more on advanced features and immersive experiences. To evaluate these devices, I used 8 usability principles: consistency, universal usability, feedback, closure, error prevention, reversal of actions, user control, and memory load. These principles provide a structured way to analyze how intuitive and effective each interface is. Consistency refers to how predictable and uniform an interface is. The Ray-Ban Meta glasses use the same interaction methods, voice commands, and touch gestures for most tasks, making them easy to learn. The Xreal Air 2 relies on different control systems depending on the connected device, which can create inconsistency. Ray-Ban Meta provides a more predictable and user-friendly experience. Universal usability focuses on accessibility for all users. Ray-Ban Meta supports this through simple voice interaction and minimal setup, making it easy for beginners and users with different abilities. The Xreal Air 2 requires additional devices and setup, which can be more difficult for non-technical users. Ray-Ban Meta performs better in terms of accessibility. Feedback ensures that users know their actions have been recognized. Ray-Ban Meta provides feedback through audio cues, voice responses, and LED indicators. Xreal Air 2 mainly relies on visual feedback within the augmented reality display. Because Ray-Ban Meta uses multiple feedback methods, it offers clearer communication to the user. Closure refers to giving users a clear signal when a task is completed. Ray-Ban Meta provides immediate confirmation, such as voice or audio feedback, when an action is done. Xreal Air 2 focuses more on continuous visual experiences, so closure is less obvious. This makes Ray-Ban Meta more effective in confirming task completion. Error prevention involves reducing the chance of user mistakes. Ray-Ban Meta simplifies interactions using voice commands and limited inputs, which helps prevent errors. Xreal Air 2 introduces more complexity through device connections and software setup, increasing the likelihood of issues. So again, Ray-Ban Meta demonstrates stronger usability. Reversal of actions. This principle focuses on how easily users can undo actions. Ray-Ban Meta allows quick cancellation through voice commands or simple gestures. In contrast, Xreal Air 2 often requires navigating menus on connected devices to reverse actions. This makes Ray-Ban Meta faster and easier to use when correcting mistakes. User control means users should feel in charge of the system. Ray-Ban Meta only activates when a user gives commands, keeping interactions minimal and controlled. Xreal Air 2 displays persistent virtual screens, which can overwhelm a user. Therefore, Ray-Ban Meta provides a stronger sense of control. Memory load. This principle focuses on reducing how much users need to remember. Ray-Ban Meta uses natural voice commands, so users don't need to memorize complex controls. Xreal Air 2 requires users to understand spatial interfaces in multiple systems, which increases cognitive load. As a result, Ray-Ban Meta is easier to use and learn. Overall, the Ray-Ban Meta smart glasses provide a more usable interface for everyday interaction. They focus on simplicity, voice interaction, and minimal cognitive load. The Xreal Air 2 offers more advanced visual capabilities through immersive augmented reality displays, but its reliance on external devices makes it less accessible for casual users. This creates a clear trade-off between usability and functionality. In conclusion, Ray-Ban Meta is better suited for everyday users due to its simple and intuitive interface. The Xreal Air 2 is more suitable for specialized tasks that require immersive visual environments. However, when evaluating usability, simplicity proves to be the more effective approach. These are the academic and industry sources used to support this analysis, including work by Shneiderman, Norman, and Nielsen on usability design principles. Thank you very much for taking the time to watch this presentation.